Okay, segment 3, we're going to be diving right in to stoichiometry. So, solutions and reactions, taking stoichiometry to our another level, and this is our last level, right? So we've done solids, where we did mass to mole, mole to mole, mole to mass. Then we did gases, so we looked at piv inert, solving for mole there, putting that into mole to mole, then from there going to solving for volume using again PV equals an RT. And now we're going to look at how do we deal with stoichiometry when it comes to solutions and molarity. So again, it's the same problem, that same three-step situation. We'll jump right into a reaction. Zinc reacts with HCl to produce zinc chloride and H2 gas. So before, just like now, and then we have to write our reaction out using symbols. Then we'll calculate the needed quantities. So the first thing we come up with is our reaction. Zn plus HCl goes to Zn2 plus H2. And of course, we need to balance it. That's the very first thing we need to do after we come up with it. And so I'll give you a second there. Hopefully, right, you need a 2 in front of HCl. So that's our reaction. So now the question was how many liters of 0.5 molar HCl solution completely reacts with 6 grams of zinc? So just like before, we'll take that 6 grams of zinc, we'll figure out how many moles of zinc that is. So that part's not changing. Whoops. Get rid of that real fast. All right, so we're going to take 6 grams of zinc. We're going to go to our handy dandy periodic table. 1 mole of zinc is 65.38 grams. 65.38 grams. So we've got 6 divided by 65.38. That gives us 0.09 moles of zinc. All right, the next thing we would do is use our balanced chemical reaction and figure out moles of HCl. So that's not changing either. 0.09 mole of zinc. All right, and for every 1 mole of zinc, I need 2 moles of HCl. So that's going to be 0.2 moles of HCl. And now here comes the change. How many liters of HCl? So now I've got 0.2 moles. We want to know how many liters. So now we know we have 0.5 molar. So that's going to be 0.5 moles for each 1 liter. So 0.2 divided by 0.5 gives me 0.4 liters. And so that's going to be 0.4 liters of 0.5 molar HCl. So again, our only step that's really going to be different here is that last step, or even that first step, if it's going to be in solution. Okay, let's try one more problem. All right, so here's a little bit of an added slide for us to do this problem. And so we've got how many grams of ZnCl2 are produced when 5 grams of zinc is treated with 500 milliliters of 6 molar HCl. So this would actually be a limiting reagent style problem, right? So we have to figure out our stoichiometry with the 5 grams, and we also have to do the 500 milliliters of 6 molar HCl. So the first thing we're going to do is figure out 5 grams of zinc. So we'll take the 5.00 grams of zinc. It's going to be a 3-step process here. do 1 mole of zinc on top. This is going to be 1 mole of zinc to 1 mole zinc chloride. This is going to be 1 mole of zinc chloride. All right, so periodic table time, 65.38 grams. Two chlorines and 1 zinc gives me 136.28 grams for the product. All right, so I'm going to take 5, going to divide that by 65.38, then multiply that by 136. That tells me we're going to make 10.4 grams of product. All right, now that's if the zinc is the limiting reagent. What about at the HCl? So now what's going to change now is that first step, right? So the two middle steps will be identical. We're looking for that same zinc chloride product. The numerator in the middle will stay the same, right? Because that's based on the balanced chemical equation. So that's going to be 1 mole of zinc chloride. The denominator is going to change because we need 2 moles of HCl, right? And then this first step is going to change because we know we have 500 milliliters of 6 molar. So that first equation is actually going to be our concentration, right? We want moles. We want to get rid of liters. So this is going to be 6.0 moles on top, 1 liter on the bottom, which means I need to convert my 500 milliliters into liters. So this is going to be 0.5 liters. All right, and actually that should be 0.500. Keep my sig figs there. So we have 0.5 times 6 divided by 2 times 136.28. And that tells us we're going to make 204. So yeah, well, we only get 2 sig figs. So 200 or 2.0 times 10 to the 2 grams. So zinc is our limiting reagent. However, we had to be able to figure out that concentration for our acid, right? We had plenty of acid to get that done. All right, so that's stoichiometry using solutions. We've done both a solution in the front and figuring out volume as a product in the end. The beautiful thing about this question right here is I can hit all 3 physical states. All right, so if we were to put this in, this would actually be a solid in the lab. This would be a liquid in the lab. This is aqueous. And then this would be a gas. So it'd be easy to take the same reaction then, same question, and ask you how many liters of hydrogen are produced at STP. And now I've tackled 2 things, right? Actually 3 because I got mass in the beginning. All right, so anyway, you want to give that a practice. The only way to get good at it is to practice it. From there, we're going to get away from math and get into colligative properties. So I'm going to stop the segment here, and then we'll pick up segment 4 and finish out properties of solutions. So stay tuned.